Buses. Buses is another interesting part in the microcontroller. Um, Generally, we have bus, right, in our normal transportation. What the bus is doing, we are taking sometimes bus. So bus is helping for the transportation. So it transport or transmit one person or the people from one place to another place. In microcontroller is also the same. Bus is helping to transmit or transport data from one location to another location. So inside the microcontroller, I have so many blocks. So now I am just transferring, maybe this is the ADC block. So I convert the analog into digital, signal into digital data. I have so many digital data, 0, 1. So maybe 4 bits I have. And here I need to read this data into the ALU. So this is called bus. It's just a wire. So it's just transmitting this data from one block to another block. And we have so many different types of buses. Mainly we have the address bus. We have a data bus. Simply we can also call as a system bus. And we also have the bus for the clock signal. Okay, so these are generally this is what bus means. And of course, they are also based on the implementing this bus. It has to also follow some architecture. So for example, STM32, they were using Harvard architecture. And the system bus, there is also giving some control signals, how the data should be. It should be synchronized with the clock signals when we transfer the data. So, and also private peripheral bus. Of course, if you have some peripherals, external peripherals or internal peripherals, how you are going to exchange the data. So, and you should also have the on-chip debug system. If there are some bugs came, then you have to debug. You have to modify the problem. First, you have to diagnose the problem, where is the bug, and then you have to debug that. And also the bus matrix and how many number of buses are connected to the internal world and external world, and so on. So in STM32 microcontroller, you have two important buses, we can say. First one is called AHB, that is called high speed bus. Actually, this is a system bus. This is mainly responsible for connecting some internal interfaces such as processor and DMA. So inside the microcontroller, there are so many units, and these AHB buses are mainly used for high-speed data transfer internally. So AHB system means AHB system bus. It's composed of 3 parts. One is called the master module, another one is called slave module, another one is the basic structure. So this is the data, just you have to remember. And the transmission on the entire AHB bus is sent by the master module and slave module. Master module and slave module is responsible for responding. So maybe, for example, I have the data transfer here. I have the master module. I have the slave module. So when I transfer the data, it has to give the acknowledgement back. And APB, it's a low speed bus. Remember, AHB is a high speed bus and APB is a low speed bus. And what is the duty or responsibility of this bus? It's mainly responsible for connecting peripheral devices. So we have so many peripherals, counters, timers, ADCs, and so on. So all these peripherals are connected to the CPU or ALU through this APB bus. And APB is divided into APB1 and APB2. Again, and its bus architecture is not like AHB because it supports multiple main modules. The only main module in APB is the APB bridge. Remember, AHB has multiple main modules. It has a main module, or it means master module, slave module, basic structure. It has so many main. But here APB, it does not have multiple main modules, but it has the APB bridge. So this APB bridge is the one connecting AHB and APB. So everything is just connected internally. And APB1, the maximum clock frequency is 36 megahertz. APB2, the maximum clock speed is 72 megahertz. So that's all. So we have AHB, that is for high speed, and we have APB, and that is for low speed. And the APB can further classified into APB1 and APB2. And this APB1 has 36 megahertz, and APB2 has 72 megahertz. So whenever you transfer the data, this is the clock speed it will follow. And the AHB, it has the main module and slave module, and then the basic structure. Okay, so that is the bus mainly. So the AHB again, it's a high-speed bus which is mainly responsible for connecting internal interfaces. So the same data, I think here, this is the architecture. So now you can see very clearly where it's located in the microcontroller. So this is not the entire microcontroller, it's part of the microcontroller. Here you can see AHB bus, that is the AHB system bus. So this is for transporting high-speed data between the clock module, and then we have this SDIO module, and we have the bus matrix. And here we have the APB1 and the APB2, that is the low-speed bus. These low-speed buses are connected to all the peripherals. So for example, ADC is a peripheral. This microcontroller has 3 ADCs. That's why 3 ADCs are here, ADC 1, 2, 3. And USART, SPI, timer 1, and timer 8. It means like so many timers are here. And GPIO-A, general purpose input output register, A, B, and so on. So these all are peripherals which are connected to this APB. So whenever this one is processing the data will be going to this APB, and then there is a bridge. In the previous slide, we had seen already this APB is using the bridge, and the data is going to the bridge, and then going to this via this system bus, and then going to the bus matrix, and then shared between so many other modules. Like it can be the DMA2, for example. Here it's connected to the DMA2, and here it's also connected to this Cortex-M, and so on.